Okay, well, hello everyone. Welcome to our Tuesday Safer World by Design webinar. And today I have, as you'll see on the screen there, Daniel Bachler is joining us from Berlin. And I'll hand over to him in a minute. His topic is going to be on COVID-19 data and how to organize it with Edelweiss data. It'll be, I think, something like 25 minutes presentation-wise. If you're used to these GoToWebinar, you'll realize there's a place where you can enter questions at any time, or you can put a comment in the chat, and hopefully it's not too difficult to figure out. Just look at on your panel there on the right-hand side. So with that, hopefully we'll talk later with some discussion at the end, and I hand over to Daniel. Off you go.
Okay, perfect. Thank you, Barry. Okay, so let's see. I'll switch this off now and turn over to the screen. Okay, that should be presenting. Barry, can you quickly confirm that you can see my screen still? It tells me
it's fine. You're on your first slide.
Perfect. Okay. Okay. So as Barry said, there's a brief overview of some of the data repositories that we started indexing for COVID-19 data that we started indexing with EdelweissData, and some of the small use cases that we did with that, which I think also shows nicely what EdelweissData can be used for, and hopefully is interesting for some of you. Okay, so let me give a brief outline of what I'm going to talk about in the next half hour. So first we'll have a look at a case study. This is a dashboard for Slovenia. So some of us were involved in a crowdsourcing effort to improve the data collection and representation for COVID-19 data for Slovenia. And we used EdelweissData for that. Another one was a simple notebook that was based on this idea that you could estimate COVID-19 or SARS-CoV-2 cases, to be more exact, infections from the number of registered deaths, and that this might be an interesting alternative metric. I'll talk a bit about, in general, what is EdelweissData, what does it do. Then I'll quickly show how to use COVID-19 data that is served from EdelweissData with Jupyter Notebook. If we still have time, I'll make a brief excursion in how to do things like nightly data imports, in this case using GitHub Actions, which is, I think, quite a nice trick sometimes to use. And maybe we'll still have time to look a bit into more concrete cases of how to use metadata in EdelweissData for data collections like this. If you have any questions, I'll try to keep an eye on the chat. Please just ask them right away. Otherwise, as Barry said, we'll have a small question and answer session at the end. Okay, let's jump right in. So the dashboard for Slovenia. So this is something that some of us were working on from March. At that point in time, in Slovenia, there wasn't really any good data source that the government provided. There was one website that was really cumbersome to navigate, didn't give much information. And so some of us got involved in that, in this grassroots effort to collect more data and better data and communicate it better. And what happened here is that just as these things often happen, so in the beginning, a lot of the collected data was just stored in CSV files. They were served with GitHub, and usually that works fine in the beginning. But over time, as the dashboard became a bit more powerful and a bit nicer, there were some bits and pieces that were starting to be a bit problematic, like doing things in a browser with when they tried to add country comparison, for example. It proved to be just about the data amount that they started using became a bit much for some of the older browsers, and that was where Edelweiss Data became quite handy. So maybe to give you a brief look at what this looks like. So this is the dashboard that was created. As you can see here, there's various markers here that say when schools were closed and when shops started to have special restrictions, and when people were supposed to be to not leave their homes and so forth. You can see the different curves for the active infections, for the number of people deceased, and for the confirmed cases and so forth. And so it's like a lot of these dashboards that have been created, of course, but I think it's quite well done. It looks quite nice. And the thing that I mentioned were it then especially became very handy to have Edelweiss Data in the end was here where the country comparisons were added and the number of data points just became a lot more. Instead of a few hundred data points, now you have I think 200 countries or so, times by now 120 days or so into the past, and several different variables that you could compare. And so here it became quite useful to have to have APIs available. This is what Edelweiss Data provided here, that allowed easy filtering of data, serve the data as JSON and so forth. So this was one of the parts where it was used in this case. Another thing that we did when we started looking for interesting data sources and think a bit about the development in March was there was this idea that could you estimate the number of actual infections from the number of deaths, given that maybe the number of deaths are recorded with a higher fidelity. It's harder to miss deaths than it is to miss infections, where many of those are maybe asymptomatic and don't have any good reason to get themselves tested. And so here, the basic idea is that if there's a given infection fatality rate or ratio of, at the moment it's estimated still about 0.7% plus minus a little bit, so that's around 1 in 140 cases. And then the basic idea is that if you have a number of deaths that you have recorded today, by today, that you can then make this estimate that you probably had around 140 times that many cases already 23 days ago. So 23 days is the average interval that it takes from infection for somebody to die, if there are to die. And so that's the basic idea that we try to explore here. And we created a notebook. In this case, this is not a Jupyter notebook. This is a thing called observable notebooks that's a bit nicer for very interactive texts and graphics. And so the thing that we wanted for this setup was we wanted it to be easy to switch between different data compilations. So we wanted to have a national compilation. In this case, we used the one of the European Center for Disease Prevention and Control that was compiled by Our World in Data, which do an excellent job of compiling that data. But we also wanted to be able to easily provide additional data sources. So, for example, the German state level data compiled by the Robert Koch Institute, or the US state level data by the New York Times. And the basic idea here is that we have this curve, which is the number of cumulative deaths that have been confirmed. In this case, we're currently switched to the country of Berlin of the German state level data. And then we do basically this estimation that I just described. We go 23 days into the past. We multiply the number of deaths by the infectious fatality rate. And then we arrive at, for example, so here at the border between the orange and the blue line, at 140 times the number of today's deaths. And then the blue line, so the green line is the number of deaths that we estimate. The blue line is the number of deaths that have been actually tested and confirmed in the official number compilations. And so for this this notebook was something that we also thought that that's an interesting idea. This came from a Medium post that maybe some of you have seen by Thomas Pueyo, Coronavirus Act Today or People Will Die. Was a very widely read Medium post in March, and this notebook just tried to make it a bit easier to check this data and see what it looks like for various regions, and make it easy to look at these things. So just one more example. Let's have a look at France. And then, as you see, the numbers, they update interactively, and you see the different curves and so forth. Yeah, that was those were two cases where we started to get interested in this and thought maybe Edelweiss Data is a nice tool for these things. So what is Edelweiss Data? Maybe if some of you might have heard of it, some of you probably haven't. So very briefly, it's a platform for managing mostly tabular data sets. The key features are, one, it has a rich metadata support, so you can store not just the tabular data itself, but also basically arbitrary additional structured information. It has strong versioning support, so you can always go back and see what the data looked like. So all the versions are immutably stored, and you can always see the history. There's a nice set of interactive web UIs that allow you to check the data, filter it, go through it, and so forth. And these web UIs are also tightly integrated with APIs. So these are REST APIs, if you know those, that work very well with all sorts of tools. So no matter if you prefer to work with Excel or with Python or with R or with KNIME or basically any other programming language or workflow tool that you can think of, it's very easy to work with these REST APIs with them. And so it's very easy to get information about a lot of data sets, filter the ones that are interesting for you, and then consume and filter the actual data. In Edelweiss Data, every data set has 4 parts. One is the tabular data itself. Then you have the schema, which is describes each column in more detail. So you have descriptions, data types, things like that. Then you have the metadata JSON. So this is structured machine readable metadata where you can store additional information about this particular data set. And so a description or a README that works very similar to the READMEs in GitHub, for example, that you might know, where you can describe the data set, the origin, how to use the data, annotations, and so forth for humans that are interested in those. Okay, so quickly, how did we then end up using Edelweiss Data for these two cases? So in the Slovenia dashboard case, it was important that it was easy to import the data. And then the key feature that was interesting was that Edelweiss Data immediately gives you these JSON APIs that can serve up data and filter it. And so they could add to the dashboard these country level comparisons where only exactly the data points that were needed could be retrieved. And it's served up in JSON, which this is a web dashboard that's written in JavaScript. So that's the easiest thing that you can consume is JSON basically in these cases. And so it was a very nice fit over there. It was also very nice that we could easily set up automatic updates. So every night, a couple of data sources upstream data sources are downloaded, ingested. Sometimes they're cleaned up a little bit, but mostly they're just republished every night as new versions. And so you have the full version history for the Johns Hopkins data set, for example, for the Our World in Data data set, for the Robert Koch Institute, and for the New York Times state level, US state level data. We'll take a look at the actual data sets in a minute. I just wanted to get these two cases first briefly described. Okay, so in the case estimation notebook, so here it was very nice that the data sets had the ability to serve additional metadata. And what we could do this way is that even though the different data sets and data releases that are done by, for example, Our World in Data, by the New York Times and so forth, they all have, they contain similar data, but they all like give it different names, of course. So in, for example, the easiest thing is that the German state level data uses German column headers and so forth, and the others use English headers and so forth. And the metadata allowed us to describe these differences for the different data sets and then unify them. And so you can write the notebook once and then just switch the underlying data source, the URL that it uses to get the data from. And the same notebook can be made to work with many, many different data sets. Okay. Now I want to give you a brief overview of how to consume the data with your favorite tool. As you can see, this is the URL EdelweissData.com. I'll talk a bit about this later. So we're planning to have a public version of this running in public beta very soon that you can use to also host your own data sets if you deal with data. At the moment, this is still a bit of a placeholder that only people from our company can register at and publish data at, but very soon you'll be able to use this as well. At the moment, as you can see, we have only these couple of COVID-19 showcase data sets in here. As I mentioned before, we have, for example, the Our World in Data dataset, the US state level data by the New York Times, the German Robert Koch Institute data, and the John Hopkins datasets. And if we want to take a look, for example, now here in the browser, so this is what a single dataset looks like in Edelweiss Data. So here we have the Our World in Data dataset. We can see the various columns here. So you can see that Our World in Data by now publishes quite a lot of additional pieces of information on the population of the various countries and so forth. Edelweiss Data allows you to easily filter. So for example, if we're interested in the data for Germany, we can just filter by that, and we can have a look at the various different columns and data points and so forth. As I said before, there's 4 pieces of information that every dataset has. So one is the tabular data itself. Then we have the description. So this is like the README on a GitHub repo, basically, where we say, this is where the data comes from. Go here if you want more information about how it's collected exactly, and so forth. Then we have the metadata. So this is the JSON. Let me make this a bit bigger. This is the JSON structured metadata that's easily machine readable. I mentioned before these column name mappings, for example, that we can do here so that different data sets can carry with them the information of what the daily cases, for example, what are they called like in this data set? What's the column header for this piece of data? But we also have other pieces of data, like, for example, what is the original data collection agency, what's the upstream data source CSV file, and so forth. Here we have the schema, so that's the list of every column, basically, and gives you the data type. Here we could have additional descriptions and RDF predicate if available, and so forth. Although in this case, we're not making use of those. And then we have the version history. So here you can see that we're doing this once a day, every day for 36 days now. Before that, we had a different data store. So this has actually been going back to March, but in this particular public data repository, it's been going on since April 27th. Yeah, and that's basically a very quick rundown through Edelweiss Data. The interesting, a lot of the interesting features are then also in finding data sets. So here, as I said, we only have these 7 data sets, which doesn't really allow me to show many of those features. But we have other installations where we have 40 or 50,000 data sets, and then just managing the data and using the metadata to find data sets, to filter for them, of course, becomes the main job. And this is where things like these features with the faceting, where you can filter on different terms that come up in the metadata, become very useful. Okay, but now to just briefly show you how the data can then be used in different tools. So for example, I live in Berlin, so if we filter the German state level data to Berlin, we now see only the data points for the state of Berlin. And then I think a tool that probably everyone here knows well would be Microsoft Excel. So let's start with that and see how easy it is to get data into that program. As you can see up here, we have two buttons. One is for the APIs. So this is for if you are a Python programmer or like to work with the command line with curl or with R, then this is for you. We'll have a look at this in a second. But the other one is just a CSV file, and you could just click here and download it. That's the straightforward way of doing it. And then you have a file, and it's filtered. It's the data exactly as you see it here. So it's filtered in this case to the state of Berlin. But what you can also do is you can copy the link address, and then if we get the Excel window over here, make a new workbook and say we have a data source that we want to ingest from the web. Okay, where does the window open? Here we go. So I paste in the URL that I just copied, and then it fetches the data from there. As I said, it's exactly filtered as you saw it. So if you only have a couple of hundred rows, like in this case, I think I have about 130 or so, then this is all that needs to be transferred. Of course, I can also get the unfiltered data, but in this case, let's say this is what I want. And then, for example, if I want to make a simple curve of the total cases, then I can just select this here, insert recommended chart, and sure, line chart looks fine. And I have used Excel to ingest this data live from the web. One of the nice things about this, as opposed to just working with CSV files all the time, is that tonight this data set will get updated, a new version will get ingested, and if tomorrow I open this Excel file and I click here and I just say refresh, then it will refetch the data and I will have the next data point added. So this link is live, and that's one of the things that are I think quite nice when you start using data in a way that's versioned like this. The other thing that I wanted to briefly show was using the Python APIs. So we have a Python client. There's an extensive documentation here. As you can see, the library is called EdelweissData. It has, if you're a Python programmer, you'll should see that, find yourself at home immediately, I hope. And what it tells you here is that if you want to get the data into a pandas data frame, which is the thing that most Python programmers will probably want to use, then just copy this piece of code here and paste it into a notebook. So let's quickly do this. I'm using Nextjournal here, which is very similar to Jupyter Notebooks, but has a slightly better support for versioning and reproducibility. So let me just delete this logo here. Where's delete? Here. Delete. And now I need to do two things. One is I need to install the Edelweiss data library. And the other thing is I need to copy the code that I just copied in the window where it gave me the pre-formatted Python code. So I'm pasting this in here. Okay, up here it has started the library installation and it's complete. And so now here I say, okay, this is the code that I just copied. As you can see here, it put in the query that I had for in the column for state. I want to filter to only the values that have Berlin in them. So if I now click run, then this gets executed. And now I have a Python data frame. And so if I have a look at this now, I can see that I got the data that we just saw in the web browser from before. Of course, all the same things that I just explained with the versioning and so forth, all that applies here as well. So if I have a Python script like this and tomorrow I run it again, then I can get the same the data with the updated data points for today. And of course, here if we were to plot this, let's briefly do this and then move on to the next. So let's say we want date here, and for Y we want total cases, and then I need to figure and execute, and I hope I did everything right. Nope. To figure, what's it called? Get figure. Get figure. Here we go. And you have your plot, and you can now do whatever pandas, kung fu you want to do with it in Python. The same thing also works with R. It also works with KNIME, with other programming languages. If you're a Java programmer, I mean, really whatever. It's these are all just REST APIs. They have a Swagger documentation, so you should be able to find your way around this quite quickly. Okay, so how are we for time? Yeah, I think I have another 5 minutes. So let me briefly show you two more aspects in a bit more detail. One of them is unifying data sources. So this is something that I said about this notebook, right? Where one of the things that we wanted to be able to do was to have not just one data repository. So for example, now I have the data from the European Center for Disease Prevention and Control, and I can switch between the different countries, and that works well, and that's nice. But we said it would be really useful if this one notebook could also then just switch between data sets. So the switch down here is just switching between data points within this one data set. But here we added another drop down, and that just switches the URL for the data source that is used here now. And then, for example, we can switch to the US state level data. Now we see the New York data. So these are the deaths and the cases. So again, the blue line is the confirmed cases. The turquoise one are the estimated cases that we calculate back from the confirmed deaths. And down here, the red line is the confirmed deaths that were recorded. There's a couple of parameters here, like you can, if you think that the infection fatality rate is something different, you can just change this here. So for example, if you think it's a bit higher, if you think it's more closer to 1%, all of this updates immediately in line. So both the numbers change in line, and the graphs are updated. So I hope you see that in the that all of this goes interactively in the webcast. But yeah, so here the idea was it would be nice if we could easily switch different data sets and then have use the same notebook with different data repositories with different levels of granularity. And the way we did this was, as I said before, if we look at this in Edelweiss Data, you'll see that here, this is the German state level data. This is the unified data. So here the names are already English, but the original data set, it has German labels for the different columns, and the OWL data set uses new underscore cases, and the New York Times data set uses cases as a label, and so forth. So there's these discrepancies, and you want to write the code for the notebook only once, and then you want to have a single column name basically to work against. And so what we did here is we used the metadata for this. So each of these data sets has a section in the metadata where we say column names, and then we use the same label all the time. So for example, we always say total cases, and then we say to what label should this map in this particular table, right? So if you were to look in the Our World in Dataset data table, then you have the name that's used there as a column label is total underscore cases. And in the New York Times dataset, it's cases, and in the Robert Koch Institute dataset, it's Anzahlfall. And so by using this, the notebook can make use of this metadata JSON, use this mapping, and then we write the code once. It takes this mapping into account that is always stored with the dataset together in this metadata JSON, and then one notebook can use as many data repositories as we publish in this form with this mappings enabled. So I think this is this can be quite useful. So very often you have additional pieces of data for your tabular data set that you would like to store pieces of metadata. And JSON is a very flexible way of doing this and easily consumable. Okay, and now as a last thing to finish up with, this is how we do the periodic data imports. So, and I thought this is maybe also useful for other tasks that are not necessarily related to Edelweiss Data, but this is a task that comes up every now and again that, in this case, for example, in New York Times, every day, I think around 9 o'clock in the morning, Eastern Standard Time or so, they publish the updated data set with the cases from the last day. And what we would like is to have every day an automatic import of this data set. And GitHub Actions is a thing that I'm assuming that many of you know GitHub, a place where you can store your source code. And GitHub Actions is a tool, a workflow tool that they have where they basically run code for you. It's usually used to just test, like compile code and test it. That's what it was built for. But because you can just run arbitrary code and they run it for you, and in public repositories, or if you're a paying member, then in either of these cases, you basically have a lot of free minutes to just use these hosted code execution environments for you. And so what we did is we used those for ingesting this data. So one way of using this is to use a cron schedule. And this is just a bit of a strange notation of specifying how often do you want this to be run. So this is every 15 minutes after 15 o'clock, 3 p.m. On every day, every weekday, something like that. Every star has one of these connotations. I always have to look them up. But basically, it runs it once a day at 3:15 p.m. And then the thing that you should run is a Python script, right? It's in the same GitHub repository as this GitHub action file, which is just this simple text file that describes it. And then GitHub will understand this and run it for you. And this is a very convenient way of doing something like this, where you don't have to bother with setting up a server and having a cron job there, and then what happens when the server is down or whatever. You just use GitHub Actions for periodic publishings like that. Yeah, and so that's how we import the COVID-19 data. We have this repo available here. It's a public repo, so you can have a look at this. So these are Edelweiss Connect /COVID-19. Edelweiss Connect is our company name still on GitHub. COVID-19 is the repository where we have these workflow scripts. So if you want to take a look at how this is done, in data import scripts, we have the various scripts that are downloading the upstream data with Python and uploading it into our Edelweiss Data installation, and the workflows that I just described, these GitHub Actions things, are all in here. So you can take a look at that if you like. Okay. This brings me basically to the end. So as I said before, we're currently working on making EdelweissData.com the public version, like finalizing that and making it open to scientists and data scientists from all over the world. The idea here will be that you will be able to host your own data, your own tabular data at our platform. We're aiming at the moment at a release still in June. So basically watch this space, and we'll definitely have in the SaferWorldbyDesign newsletter, we'll point to it when it's done, and then release more material that explain it again in more detail and so forth. Until then, many of you probably know our SaferWorldbyDesign website. If you're interested in any of the examples that I showed, we have a section up here now for the COVID-19 data that explains how we did this. So basically the two showcases that I I showed to you. We have some text here, links out to them. We described a bit how we use Edelweiss data for it, if you want to read up on this again. Yeah, and with this, I'm at the end. Thank you very much for listening. If you want to have a look at the slides again, they're available under this URL. And with this, I'm done and yeah, open for questions.